All right, let's jump right in. What we're going to do here is build a visual map of how obesity works inside the body, step by step. The idea is that by the end of this, you'll be able to close your eyes and literally picture this whole cascade of events. Super helpful for locking it in for exams.
Okay, so here's the game plan. We're going to start at ground zero with adipose, or fat tissue. Then we'll get into the hormonal chaos that can happen. From there, we'll trace the body's vicious cycle, see how all this internal stuff actually shows up on the outside, and then finally, we'll zoom out to look at the bigger picture. Let's do it.
So first up, section 1. We're going straight to the main character in this whole story, adipose tissue and the fat cells that make it up.
Now here's the first thing you absolutely have to understand. Fat tissue isn't just this passive blob that stores energy. Not at all. It's a super active, vital organ. Yeah, it insulates us and stores calories, but the really crucial part is that it acts as an endocrine organ. It's constantly talking to the rest of your body, sending out these powerful hormonal signals.
And this is a huge concept for exams. Not all fat is the same. Where you store it matters a lot. On the left, you've got subcutaneous fat. That's the stuff right under your skin. It tends to expand by making more small cells. We call that hyperplasia. But on the right, that's visceral fat. This is the really dangerous stuff that gets packed around your organs. It expands by making the existing cells bigger and bigger. That's hypertrophy. And these big, bloated, stressed out cells get angry. They start pumping out inflammatory stuff that leads straight to insulin resistance and heart disease.
So let's get into our next section and see exactly how this communication system run by our fat tissue can just completely break down and cause all sorts of hormonal havoc.
Okay, so fat tissue sends out these signals called adipokines. You can think of them as messengers that are supposed to keep your appetite, metabolism, and inflammation in perfect balance. When things are working right, it's a beautifully fine-tuned system.
And here's a textbook example of how it's supposed to work, the leptin loop. So you eat a meal, your fat cells release leptin, and that leptin travels up to the brain and says, hey, we're full down here. You can stop eating now and maybe burn a little energy. It's basically a thermostat for your body fat, keeping everything nice and stable.
But this is where the plot takes a huge twist. With obesity, you have larger fat stores, which means they're pumping out tons and tons of leptin. But look at the diagram. Even with all that leptin screaming, we're full, the brain just isn't getting the message. The phone line is dead. This right here is the essence of leptin resistance.
So, what is leptin resistance really? It means your brain has basically gone deaf to leptin. So even though you have more than enough energy stored, your brain thinks you're starving. And what does it do when it thinks you're starving? It makes you hungry and tells you to eat more. It's a truly vicious cycle. So let's just recap these key changes. 1. Leptin levels are through the roof, but nobody's listening. 2. Adiponectin, our good guy hormone that helps with insulin sensitivity and fights inflammation, actually goes down. That's a huge problem. And 3. The bad guy inflammatory signals go way, way up. It's a perfect storm, right? The stop eating signal is broken, the pro-metabolism signal is weak, and the inflammation signal is on full blast.
Now, all this hormonal chaos doesn't just stay in the fat tissue. Oh no! It kicks off a massive domino effect, a vicious cycle that ripples through the entire body.
And it all starts right here. This is the first domino to fall. The leptin resistance combined with that drop in adiponectin. This is the trigger. That first domino directly knocks over the next one, widespread insulin resistance. All that chronic inflammation and those free fatty acids floating around make your cells, especially in your muscles and liver, just stop listening to insulin's signal to take up sugar from the blood.
So what does the body do? It panics. The pancreas goes into overdrive, pumping out more and more and more insulin, trying to scream its message loud enough for the cells to hear. And this leads to hyperinsulinemia. You just have way too much insulin circulating all the time.
And this constant state of stress, the high insulin, the high blood sugar, the inflammation, it all leads to the final really damaging result in this chain, lipotoxicity, and even more systemic inflammation.
Okay, lipotoxicity. This is a must-know concept. It's exactly what it sounds like, fat becoming toxic. When your fat cells get so full they just can't store another drop of fat, that fat has to go somewhere, so it spills over into organs that aren't meant to store it, like your liver, heart, and muscles. And this fat overload is literally toxic to those cells, causing them to malfunction and even die.
So we've gone through this whole internal battle at the cellular level, but how does this chaos actually show up on the outside?
What do we actually see clinically?
You've probably heard of the apple versus the pear shape, right? Well, this is the why behind it. The apple shape is from that dangerous visceral fat we talked about, the kind that's strongly linked to metabolic syndrome. The pear shape is when fat is stored more in the thighs and buttocks. It's still a risk, but it's less metabolically active. And this is exactly why something as simple as a waist measurement is so important. It's a clue to where that dangerous fat is hiding.
And here are the long-term consequences. Look at this list. Every single one of these major health problems, heart disease, type 2 diabetes, even certain cancers and fatty liver disease, you can draw a straight line from them right back to that cascade of inflammation, insulin resistance, and lipotoxicity we just walked through.
All right, to get the full picture, we have to zoom out for a second and remember that fat tissue isn't acting alone. There are other major systems that play a role in all this.
And this table gives you a great snapshot of those other key players. Your GI tract has hormones like ghrelin, the hunger hormone, that get all out of whack. Your nervous system has its own pathways that can drive appetite. And now we even know that the bacteria in your gut, your microbiome, can affect your metabolism. It really shows you that obesity is a true multi-system condition.
Which brings us to our final thought. After walking through this entire complex biological cascade, from broken hormones to cellular resistance and organ toxicity, it really forces you to ask a fundamental question. Is obesity a disease of willpower, or is it a disease of broken physiological signaling?